Good morning, student. Namaskaram. Today we are going to discuss another one problem, which is belongs to 11th physics. Chapter name Motion in a Straight Line. Already we discussed some three, four problems in last class. Okay. Today, uh, this is a problem. A car moving along a straight highway, because straight line, motion in a straight line. So here also motion along a straight highway with speed 126 kilometer per hour. So here you can note that the unit is kilometer per hour. Okay. He is brought to a stop within the distance of 200 meter. Suppose one car is moving, we apply that brake, that car will stop, but not suddenly. It will go to some distance. Okay, that distance is 200 meter. What is the retardation? Retardation means negative acceleration. Once you apply that brake, that car or bus, that vehicle will come into stop. But some acceleration, that is called as negative acceleration, because in this scenario the acceleration tends to decrease. Okay, acceleration tends to decrease. So decrease means that car will with moving with some acceleration. Once you apply the brake, it will come to with negative acceleration, means it will slowly decrease with a change in speed. Yeah. Okay. So that's why we calling it retardation, negative acceleration, retardation of the car. That is assumed uniform. Okay. In all this case, which is in the environment of straight line motion. Okay. So and how long? How long? Okay. How long it does it take for a car to stop? How long means how many seconds or how many hours or how many means okay. But in terms of in a car or bus, the that vehicle will come into that come to stop within the a second. Yeah. So we have to find time with a unit of second. Clear? Okay. Okay. So now we can go into that sum. First of all, uh, in this case, in this problem, to find the retardation and time taken for the car to stop, we have to apply equation of motion. Already we are familiar with the equation of motion. Yeah. So initial speed, final speed, acceleration, time is also included in that equation. Yeah, correct. Okay. So sorry. So we have to apply equation of motion. What are the equations of motion we will use in this case? That is v square is equal to u square plus 2as, one equation. Another one is v is equal to u plus at. Okay, these are all two equation we got to apply in this sum. Okay, so here what are the data given? That is u, initial speed. Initial speed here 126 kilometer per hour. Yeah, 126 kilometer per hour, which needs to be converted into meter per second. Okay, so here already I told you, here 126 kilometer per hour. We have to convert this unit into another term of unit, which is a basic unit, that is meter per second. Final velocity. This is initial velocity. This is final velocity. That car will comes to stop. So final velocity is no. Okay, the final velocity is 0. Okay, 0 meter per second. Since a car comes to a stop, distance. So generally we denote the distance. Yes, yeah. So distance 200 meter. Correct. Okay. Okay. Now you are familiar with that equation and data. First step, we have to convert that 126 kilometer per hour into meter per second. So already we are know. Okay. So U equal to 126 kilometer per hour. So 1 kilometer in terms of meter, that is 1,000 meter. Yeah. So 126,000 meter because 1 kilometer in terms of meter, 1,000 meter per hour. Hour in terms of second, for 1 hour we have 3,600 seconds. Yeah. So we have to multiply that quantity 1,000 by 3,600. So kilometer per hour. Suppose if you want to meter per second into kilometer per hour, in that situation, you have to multiply 3,600 by 1,000. Okay, so uh, just calculate that. Okay, so 120 kilometer per hour. Okay, so 126 into 1,000 meter by 3,600 meter per second. We can cancel this to 0. Okay, so 126 into 10 by 36. You, you can calculate. So I have a final answer. This is, please check without your own calculation. So 35 meter per second. Okay, 35 meter per second. You can cancel out like in terms of 5 or 2. Okay, so whatever. Okay, so 126 kilometer per hour in terms of meter per second, 35 meter per second. So we have U. So V square minus V square equal to 2 V square equal to 2 U square plus 2AS. V is 0, U 35 meter per second plus 2 A. We don't know A. Okay. So we have to find A. But S is there, that is 200 meter. Okay, 200 meter. We have to find first A and then we will go into the time. Okay, so 0, 35. So you have to square. So 35 meter per second. We can take that unit and 2A 200 meter. Clear? So 35 square means 1,225. Yeah. 1,225. And 2A into 200, 400. 400 A. So that term goes into here. So 400 A, which is equal to minus 1225. A means 1225 by 400. Yeah, we can cancel or divide. So I have an answer that is minus 3.0625 with the unit meter per second square. Please check with that own calculation. A is equal to minus, because minus means negative acceleration. Negative acceleration means retardation, because in this case, the brake applied. Yeah, that car will comes to rest, will comes to stop. Okay, so that's why here also the negative sign is there, minus 3.0525 meter. Okay, right. Then we will go into that another equation to find the time taken. That equation is V equal to U plus AT. Clear? That equation V is equal to U plus AT. U plus AT. Already we have V, U, A. So V 0, U 35, A. Now we have minus 3.0625 into T. Clear? Okay. So here that minus part go into here and it becomes as plus. So plus 3.0625 T equal to only 35 here. Yeah, 3.0625 T equal to 35. So for T, that term goes into here, that is divide. So 35 divided by 3.0625. You can divide 35 3.0625. The answer will approximately 11.43 second. 11.43 second. Okay. So time taken. So it is the time taken for the car to stop. Approximately it takes time 11.43 second. So that distance 200 meter. Initial velocity, final velocity is there. Final velocity is 0. So when you applied brake, that car, in this case, okay, the car will comes to stop at 11.43 second, approximately 12 second. Okay, so one second, 2 second, 3 second, 4 second. Okay, so this is the time taken for the car will comes to stop. That is some that is how long does it take for a car to stop? 11.43 seconds. Okay, clear? Thank you. We will discuss another topic in next class. Thank you. Jai Bharat, Jai Hind, Jai Vidyasati.